Today we're going to be looking at writing the equations of a line of fit from a scatter plot. You've seen scatter plots before in science, or at least you will. Here's a few examples of different types of scatter plots and how they can be described. This is a scatter plot. It's a bunch of data points. Data could be something like height versus weight. And so as my height increases, there's the expectation or the trend that the weight increases. Data can change in a lot of different patterns. This pattern appears to be in a linear pattern. It's not perfect, but it's close to linear. We would call this a strong positive correlation. Strong because the data is close to the line. Positive because the data is increasing. So it's close to the line and increasing. Strong negative, well, what did we say strong meant? Strong meant it's going to be close to the line of fit, or close to each other, and negative is not going to be increasing, it's going to be decreasing. So you would look like something like this. Or again, you can see a line drawn through it. It would be very close to the line, so it's strong, but in this case it's decreasing, or it's negative. Now it's not just so easy as strong and negative, but there are things that maybe are kind of in between. We'd call them moderate. If I draw kind of a trend line here, the data is kind of far away from the line, whereas on these two, the data points are all very close to the line. So this is moderately negative correlation. Negative because decreasing, moderate because they're kind of close, but not super close. A couple more examples. Weak positive. In your mind, what do you think weak means? Far apart from the line. What does positive mean? Increasing. So if we look at an example, you can see that these are somewhat close. They're not even close to the line, but there is a kind of an upward trend. So it's definitely weak, but it is positive. What would weak negative mean? Kind of picture it in your mind before I reveal this slide. Is that kind of what you're picturing? The data is decreasing, but it's decreasing in a way that's very far apart from the line. What would no correlation be? Not all data relates to each other. There's no increase, there's no decrease, they're all just kind of random locations. This could be because some data is not related. Maybe your GPA and your age. Maybe there's no difference between your GPA and your age, or your age and your GPA, so it's just no correlation. So those are two kind of words you need to use to describe scatter plots. Are they strong, weak, somewhere in between, called moderate? Is it increasing, we call that positive, or is it decreasing, negative? So here's a couple examples just before I reveal the answer. What do you think this one is? I'm going to draw the trend line. I think, yeah, that's definitely a negative correlation. Would you say it's strong, moderate, weak? Maybe moderate. If you want to say strong, I could give you that. What about this guy? Is there really much of a trend here? Can you say that's the trend? Any more than that's the trend, or any more than that's the trend? I don't know if there's really a trend here at all. So I might go with no correlation. Or extremely weak. Alright. So when you have data, such as maybe the length of a fish, some type of fish, and the speed that it swims, what we notice is that length increases, the speed is increasing. That means that we have some type of positive correlation. Question is, do you think it's a strong or a weak one? Well, we're going to draw a line of fit here. This is not a good line of fit. There's only 1 point above, and there's 4 points below the line, so that's not a good line of fit. This is not a good line of fit. We've got 2 above and 2 below, but this line doesn't go in the same pattern that the data does. So I want to try to find a line that kind of goes in the same pattern as the other ones do. Now, what that means is that everyone could have a slightly different equation, and that is okay. Would you say the data is close to the line or far apart from the line? Yeah, if you said moderate to strong, I would think that would be okay. Anywhere, if you said moderate or strong, I'd be okay with that. So we have a strong or moderate positive correlation. Now, this is what we call a line of fit. This line helps us predict certain speeds of certain length fish. What we would like to do then is write the equation of this line. So this is where we get into things that we've been doing before. How do you write the equation of a line? Well, you need to find the slope. How do you find the slope? You need 2 points. So I'm going to find 2 points here and try to find them as, you want to find 2 nice points. We're not looking for the data points. This guy's not on the line, so don't use him. Use 2 points that you can easily find the coordinates for, like this guy. 10 comma, I must have gone up 25. I can try to go farther away if you can. Got this one, 30 comma 125. And again, I did not pick data points. I picked points on my pink line. Okay, that's what you will need to do as well. So to write the equation of a line in y equals mx plus b, hopefully you remember your first step. Your first step is to find your slope. So y2 minus y1 over x2 minus x1. It's 100 over 20, which is 5. So there's my slope. You remember though, we also have to find our y-intercept, or b value. To do that, we start with this. We have to plug in an x, a y, and an m. You can use either one of these. I'll use these two. Doesn't matter though. 25 equals my slope times my x plus b. And then we solve it just like we have been. So I get negative 25 equals b. Now that b, remember, represents your y-intercept. Does it make sense that my y-intercept would be below 0? Yeah, if I were to extend this line, we'd be going somewhere below 0. So negative 25 seems to make sense. So now I'm going to finish writing the equation of my line. Y equals mx plus a negative 25 or minus 25. And that's our answer. This equation estimates or helps us predict the data of the speed of this fish. So here's the next question. It says, what speed would a 15 centimeter long fish swim? Well, we don't know for sure, but we can use our equation to help us. So 15 centimeters long. Well, is that my x or my y or my x? That's my x. That's my length right here. So I'm going to come in, I'm going to plug 15 in for x. And I'm going to type that into my calculator. Okay, that's 50, 75, that's 50 is what you get. 50 what? What speed? 50 centimeters per second. That's their predicted speed. And you can see that from the graph. 15 centimeters would be here. There's where it crosses my line of fit, and there's my speed. So we use the equation, but we can sometimes use the graph. The line of fit helps us make predictions. Got another one here. This one doesn't have any context. It's just an x and a y, random points that do seem to have some type of trend to them. Again, let's kind of predict, or let's describe the correlation here. If I draw my trend line, and again, your trend line might be different than my trend line. Okay, we may come up with answers that are a little bit different than each other, and that's okay. Alright. If I'm describing this, my line is increasing, so I know immediately that it's a positive correlation. You say strong, weak, or moderate. These are all pretty close to the line. So I'd probably go with strong positive correlation. Now we need to find our equation of that line. All of our lines look like this form. First thing we have to do is find our slope. How do you find the slope? We need to find 2 points. So I'm going to try to find, this seems to be a good point right here. It's the point -4, -5. And I'm going to try to find another nice point. I think I'm going to use this guy right here. I'm not picking this because there's a black dot there. I'm picking it because that seems to be where the pink line crosses at a nice, pretty spot. So I'm not looking for the black points. They help me draw my trend line. My line is what I focus on now. And this is the point 3, -1. So now I'm going to find the slope. y2 minus y1 over x2 minus x1 4/7. Go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. See, I could have done rise over run. The positive slopes have a positive correlation. Now we have to find our b. To find our b, we do what we've been doing. Plug in our y, our m, and an x. It doesn't matter which one you do. I'm going to do these two right here this time. So -1 equals 4/7 times 3 plus b. -1 equals 12/7 plus b. Subtract 12/7. Subtract 12/7. And your b, and you can do this in your calculator, you should, but you're going to type in -1 minus 12/7. And you can get a couple different answers. You might get -2 5/7, or you may get -19/7. I don't care which number you use. If it's a slope, make sure your slope is a fraction. If it's a y-intercept, either type of fraction is okay. But what we want to do is make sure that makes sense. This is supposed to be our y-intercept. Our y-intercept is somewhere between -2 and -3. Well, -1, -2, -3. Yeah, our y-intercept is somewhere between -2 and -3. So that's a very reasonable answer. So my equation is y equals my slope, x, minus 2 5/7. I prefer -19/7, so if you want to write it like that, you can. Either one is okay. So there's our equation. You don't need both of them, you just need one. And then it says, what is x when y is 3? Well, I can't figure that out. Y is 3 is up here. I don't really know where it's going to cross that pink line. That pink line keeps going, but I don't really know where. So what I'm going to do is they told me my y is 3. So I'm going to plug 3 into this equation and then solve it. First step is to add 19/7 to both sides. That's the first step. Add 19/7 to both sides. I get 40/7 equals 4/7 x. Now some of you might be able to do this in your head. You can usually tell what x is by looking at those two equations. Some of you may multiply by 7. If you multiply by 7, you get this. And if you divide by 4, you get x equals 10. And that's our prediction. Alright, this problem you need to do by yourself. Let's kind of go through the steps. First, I want you to describe it. Do you think it's strong? Do you think it's weak? Do you think it's positive or negative correlation? Then, we need to write the equation. Okay, so go ahead and let's write down our first few steps. So first you're going to describe. Then you have to draw your line. Then you have to pick 2 points on the line, not data points. Find your slope. And find your y-intercept. And last, write your equation. Go ahead and pause the video, do these steps, and then we'll come back and compare. Alright, hopefully you described the line as a moderate correlation, moderate to strong, and then definitely you needed to say it was negative. Drew my line. Your 2 points may be different than mine, and that's okay. That's not a big deal. When you found your slope doesn't have to be the same as mine. As long as yours was close to negative 0.4, you probably did a good job. Now your y-intercept, which I did by solving for b, 9 2/5, I follow my line. Your y-intercept should somewhere be between 8.5 and 9.5. And if it is, then you did a good job. Then you write your equation. Last thing you need to do is write out your answer in complete sentences to these questions. How is this lesson similar to what we've been doing? And then after you've thought about that, how is it different from what we've been doing?